In sections 3.2 and 3.3, our goal is to be able to identify angle pair relationships and use them to solve problems involving parallel lines cut by a transversal. Remember last time we just talked about cutting any lines by a transversal. Now specifically we're going to focus on when they are parallel lines. Let's look at this picture of parallel lines. Now this right here, this arrow and this arrow is an indication that these lines are parallel. Not at the ends. At the ends it means it goes on forever. Here it means that they're parallel. So notice the angle measures that are here. This acute angle 70, the obtuse angle 110. In fact, if you look at all the angle measures, you'll notice that all of the acute angles say 70 and all of the obtuse angles say 110. Look what happens if I make these lines no longer parallel. So now I'm going to move point P. Did you notice when I did that? That arrow right there disappeared. Keep your eye on that arrow. I'm going to move point P and the arrow disappears because I'm making these lines not parallel anymore. Now notice as I do that, only these four angles at the top, only these are changing. However, the vertical angles are still congruent to each other, and the linear pair of angles, the ones next to each other, still add up to 180 degrees. But these four angles at the top are no longer congruent to the four angles at the bottom. Now we have four different angle measures. But if I drag P back up, so that now I've got these parallel lines again, now I only have two angle measures. The acute angles are all the same, the obtuse angles are all the same. Not only that, but the acute angle plus the obtuse angle, 70 plus 110, makes 180 degrees. So let's again notice what we have. The vertical angles are congruent across from each other no matter where we are. I can move these lines such that they're not parallel. The vertical angles will always be congruent. The linear pairs, the two next to each other that make a line, will always add up to 180. 80 plus 100, 180. 70 plus 110, 180. But what we're focusing on today is when the lines are parallel. Remember the special pairs of angles we talked about last time, such as corresponding angles, angles in the same position. Upper left, top left, top left. These corresponding angles are the same measure, these corresponding angles. The alternate interior angles are the same measure. The alternate exterior angles are the same measure. The consecutive interior angles, they're not the same measure. What is their relationship? That's right, they add up to 180, just like linear pair adds up to 180. If I make this no longer parallel, now look at the corresponding angles. They're not congruent, but if I put this back so it's parallel, we have two types of angle measures. The acute angles are congruent, the obtuse angles are congruent, and an acute angle plus an obtuse angle adds up to 180. So let's take this to our notes. Beginning with the corresponding angles postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. The corresponding angles are congruent. Let's look at how we use that in an example. Example, given line J is parallel to line M. So first thing I'm going to do is show this in the picture. Remember the arrows on the lines, not at the ends, but on the lines, show that those are parallel. I can use any type of arrows. I can use a solid arrow as long as I make it match. I can use a double arrow as long as I make it match. Parallel lines. Now, measure of angle 3 is 140 degrees. That's this obtuse angle. I'm going to write it in the picture, 140 degrees. Then the measure of angle 7 equals, well, let's go look at angle 7. Notice it's also an obtuse angle. Remember, when the lines are parallel, there's only two angle measures. The obtuse ones are the same as each other, they're congruent, and the acute ones are congruent to each other. Now, what's really important to remember is that we're using corresponding angles. Therefore, we're technically using the corresponding angles postulate. Angle 7, therefore, is also 140 degrees. by the corresponding angles postulate. Now, similar to the corresponding angles postulate, the alternate interior or the alternate exterior angles theorem. Now, why is this called a theorem and the other one is a postulate? Postulates are accepted without proof. Theorems must be proven. We'll get to a point in this year where you will be able to prove the alternate interior angles theorem. So starting just like the last one, if two parallel lines are cut by a transversal, that's the whole idea today. Parallel lines is what we start with. We must have parallel lines for any of this to be true. If we have parallel lines, then the pairs of alternate interior angles are congruent. The pairs of alternate exterior angles are congruent. Let's take a look at an example. Given line J parallel to line M, let's go mark it in the picture. J is parallel to M. So I put my arrows to show that these are parallel. The measure of angle 4 is 30 degrees. I'm going to mark it in the picture. This little acute angle, 30 degrees. Then the measure of angle 5, well, where's angle 5? Also acute. So really, without knowing that these are alternate interior angles, I know that because it's acute, it should match this one, 30 degrees. But I should know that it's alternate interior, because if I can't tell from the picture the size, by the location, I'll know that they're supposed to be the same measure. So angle 5, also 30 degrees. Make sure you've marked it in the picture in addition to your answer blank. Maybe you can try the next one on your own, pause the video, and come back and check your work. So did you do that? Let's check. Let's first label the picture. Line J parallel to line M. So I'm going to show an arrow on both of these parallel lines. If the measure of angle 2 is 120 degrees, so this angle right here, obtuse, 120 degrees. The measure of angle 7, well, angle 7 is down here, also obtuse. More importantly, it's alternate exterior with this angle. Alternate exterior this time. So by the alternate exterior angles theorem, this angle is also 120 degrees. Now we can also use these postulates or theorems in reverse, and we'll talk about the corresponding or alternate interior or alternate exterior angles converse. Let's see how the converse is similar. If two lines are cut by a transversal, so the corresponding or alternate interior or alternate exterior angles are congruent, then the lines are parallel. That's the main thing here. If we have these special pairs of angles, the lines will be parallel. So let's see how this example's worded differently. This time, notice we didn't start with parallel lines. We just went straight to the angles. If angle 1 is congruent to angle 5, let's go find those angles. I'm going to put a congruent mark in angle 1 and the same congruent mark in angle 5. Those angles are congruent. Well, notice those angles where they are in the same positions, so they are corresponding angles. So according to the corresponding angles, that's abbreviation for angle, the symbol for angle, and an S, according to the corresponding angles converse, since these angles are congruent, I can conclude that the lines must be parallel. Now, what are the lines called? J and M. So my conclusion is that J is parallel to M. See how that's done? Let's take a look at the consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. See how this one's different? All the other pairs are congruent. These are supplementary. So let's see an example like this. First, given that line J is parallel to line M, let's mark it in our picture. Line J, line M. Same arrows on the lines to show they're parallel. If the measure of angle 6 is 140 degrees, here's angle 6, 140 degrees. Then the measure of angle 4 equals, well, where's angle 4? It's not obtuse like angle 6. Here it is. It's an acute angle. These two angles right next to each other, in between the two lines, are consecutive interior angles. So they are supposed to be supplementary when we have parallel lines. 180 minus 140 makes 40. Supplementary means adds up to 180. Maybe you make yourself a note about that. Supplementary add up to 180 degrees. So the other angle has to be 40 degrees. They have to add up to 180 degrees. Let's check out the converse of that theorem. Consecutive interior angles converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Again, the lines must be parallel. Let's see how that works in an example. Notice we're starting right away with angles. The measure of angle 3 plus the measure of angle 5 equals 180. So here's angle 3, big obtuse angle. Here's angle 5, little acute angle. They add up to 180. So these two angles together make 180 degrees. What does that mean? Well, these two angles are consecutive interior angles. I see that these consecutive interior angles are supplementary. They said they add up to 180 degrees. Therefore, the lines are parallel. Well, what are the lines? J and M. So that's how I conclude J is parallel to M. And that's it.